Okay, so if you worked on the review, great. If you didn't, pull it up and let's start working on it. This is due Wednesday morning, but I am hoping to get through the whole thing today. If I don't, that's fine. I'll finish it tomorrow. And then you guys can turn it in Wednesday morning. So everyone should get a fine grade on your review because we're doing it together, okay? If you turn it in late, that's on you. We're talking, guys, about 8-4 was Pascal's triangle. So you're going to need to know Pascal's triangle. You'll have one question on Pascal's. All right, your test itself is probably 15 questions long. Lots of words. But you'll have one Pascal's triangle, so you need to know the rows, 1 through 7. It probably won't be raised to the 7th power just because that's a long problem. But you need to know what the top numbers are, 1, 3, 3, 1, 1, 4, 6, 4, 1, that sort of a thing. All right, then the rest of them will be on probability and our counting principle. So permutations, combinations. What are the things to remember with a combination versus a permutation? Okay. When does order matter? Permutation. Good. Very good. Order matters here. Remember, we've talked about this a lot, guys. Order matters in a combination. Order does not matter. Does not matter in a combination. All right. There's NCR and NPR. Remember? Again, there's 2 ways to do these. You can use the formula or you cannot. When you don't, quote unquote, use the formula, you still are. That's okay. What is the combination formula? What goes on top? N factorial over what? N minus R, and then the R, right? And like you guys just told me, the difference in these two formulas, this is N factorial, and then this is just N minus R factorial. You guys see the difference here? But when you're talking about there's certain positions that you're running for, vice president, president, secretary, order matters. If you're talking about there's certain places you can place in a race, first, second, third, order matters. If you're choosing for a jury, does it matter if Alexa's chosen before Kaylee? No, because they're still on the same team doing the same job. So that's where you guys have to differentiate if it matters what order you're in. If you're arranging things, think about if you arrange something on a bookshelf in rows, order matters because not everything can be put first. Not everything can be put second. So the word arrange is something good to remember. When we talk about probability, what did we talk about probability? What's the major thing to remember for probability? How do you find the probability of something? Want over total. Perfect, guys. Very good. You guys need to be familiar with the deck of cards. What does with replacement mean? You put back, right? Without replacement means I take it out and I put it somewhere else. So that with replacement, your denominator stays the same. Without replacement, your denominator changes. What does the word and mean in math? Multiply, good. And the word or means to add, good, okay. Can anybody explain to me the difference between a mutually exclusive event, or an overlapping event? Okay, good. In an overlapping event, there's things that actually do that. They overlap, like a king that can be read or something like that. So if we have a mutually exclusive event, you just take the probability of A happening plus the probability of B. With an overlapping event, we have probability of A plus the probability of B. And then what's that last thing I have to do? You have to subtract the overlap. Good. All right, good, guys. Very good. Good little refresher. You guys did very well. So let's just go through some of these problems. We'll get through as much as we can. All right, first question. How many different batting orders can a baseball coach create from a team of 14 players when there's 9 positions to fill? Is this a permutation or a combination? Why is it a permutation? Think about it. Does everyone bat at the exact same time? Because there's 9 different positions. Can everyone come up to the plate at the same time? Somebody has to be first, then somebody has to be second, right? So order matters here. So there's two ways you can do this. And I'm going to go through this, and I'm not going to do the two ways every single time. But you can look at this and say, okay, there's 14 total, and how many positions do I fill? You can do it like this, and then set up your 14 factorial over 14 minus 9 factorial. You guys can totally do it that way. Or you can say, okay, how many spots do you have? 4, 5, 6, 7, 8, 9. How many can be the first batter? How many can you pick from? 14. Good. And then how many's left over? Then. And what do I do with all those numbers? Multiply them. Right? These two things are exactly the same. You would be showing me your work either way. I do not care which way you do it. When you multiply these together, you get a ginormous number. 726,485,760. That's how many different ways that you could have a lineup. Questions? Do we understand why that's a permutation? Why order matters? Just think about the situation. When you walk up to the plate, and again, not all of us are into sports. I get that. But if you ever watch a baseball game, does everyone stand there and the pitcher throw to everybody at the same time? No. Good job. All right, consider that 8 sprinters have qualified for the finals. What do you think this is? It's a race, right? There's 8 sprinters in a race. They've qualified for the final. How many different ways can the sprinters come in first, second, or third? Permutation, combination. So you can say 8, permutate 3, because there's 3 spots. And then go through your formula. 8 factorial over 8 minus 3 factorial. Or you can say, okay, there's 3 spots for 8 runners. So how many possibly could come in first? 8, and then what? Then what? So there's a total of 336 different ways. Questions?
Are we going to have to put like ways?
Okay, how is this one a little bit different? Does anybody remember what we do with this word? Yeah, you have to divide out the repeated. Good. How many letters total are there? There's 7 total. And then we have to divide out. When you have distinguishable permutations, you have to divide out the factorial number of repeated. Meaning, what repeats?
2.
But what letter repeats? L. L repeats how many times? 2. So I have 2 factorial. And then what else repeats? How many times? So this is what I need to see from you. That you understand the total goes on top. And whatever repeats factorial goes on the bottom. So now when we work this out, I have 7 times 6 times 5 times 4 times 3. How come I can stop at 3 factorial? Because it cancels, right. And then what happens? 2 factorial is the same as just 2 times 1, right? So 2 goes into 2 once. 2 goes into 4 twice. Again, when you guys get going like this with crossing stuff out, it's helpful if you circle what you're looking at. But when I multiply 7 times 6 times 5 times 2, what do I get? 420. Good. So distinguishable permutations, just like Mateo told us. Take the total on top and then divide out anything that repeats. Sound good? Let's do the next one. How many letters do we see here? 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, ma'am. Thank you. I believed you. I just wanted to recheck. Now, go through. Take your time. What repeats? P repeats twice, right? So 2 factorial. E is 4 times. And then what? D is 3 times. Everybody see? So I have 10, 9, 8, 7, 6, 5. I'm going to stop at 4 factorial. So I have 2 times 4 factorial times 3 times 2. So my 4 factorial cancels, right? 2 goes into 6 3 times. 3 goes into 9 3 times. 2 goes into 8 4 times. You didn't cancel with the same numbers. It's no big deal. If you don't want to cross cancel anything, you just want to multiply the top divided by the thing on the bottom, that's fine. But if the numbers are really big, you might get calculator overflow. So that might be, that's not going to be an answer on your test. So you want to go back and say, oh, let me see if I can cross stuff out. But what do I get here? 12,600? Perfect, good. Very good, very good, very good. All right, now you guys will have license plate questions and combination lock questions. And you have to pay attention to what the information is they're telling you. They'll tell you the range of the digits or the letters. And they'll also tell you if the digits or letters can repeat or if they can't. So that is the information that you guys have to decipher, not coming up to me and being like, what do they mean by that? That's the part of the question that you guys have to answer. It says, in a certain state, each standard automobile license plate consists of 3 letters. Okay, so 1, 2, 3 letters. Let's visualize it. 3 letters. And a 5-digit number. 1, 2, 3, 4, 5. Everybody agree with me? How many distinct license plate can be formed in this state? Do they say anything about the numbers or letters repeating? If they don't state anything, then you assume they can repeat. So how many letters are in the alphabet? 26. So then you could have 26, 26, 26, right? And then a 5-digit number. Well, how many digits are there from 0 to 9? There's 10. So, and it doesn't say anything about repeating, so you assume that they can. So this is just a huge number. If it said that the letters could not repeat, you'd start with 26, and then what would the second place be? 25, 24. What if it said the digits could not repeat? 10, 9, 8, 7. Okay, good. So that's what you guys have to, when you read your word problem, you just have to see, can they repeat, can they not? If it cannot repeat, then your number decreases by 1 each time. But when you do this, guys, you get, yes? Would you like to list out all those different combinations? No way. All right, 1963, blah, 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 blah. Zip code, streamline zip code. Find the number of zip codes using 5 digits. How many digits? 5. 1, 2, 3, 4, 5. Do they say anything about restrictions or numbers not being able to repeat? Anything? No. So this first one is just 10 times 10 times 10 times 10 times 10, which gives you 100,000. Good. All right. The next one, it's still 5 numbers, but it says find the number of zip codes when the second digit, so right here, is a 1 or a 9. So think about this. The first digit can be how many different, what do we have to choose from? 10. That second one has to be a 1 or a 9. So how many choices are there? 2. Good. And then the rest are what? Do you guys see how that little restriction throws a little bit of a wrinkle in there? Yeah.
Why not 9?
Because it's not 9 different ones it can be. It has to be a 1 or a 9. So out of the 10 digits that you have available, there's only 2 that it could possibly be.
So you just choose out of the 2?
No, it's either going to be a 1 or a 9. Like,
How do you know which one, if it's a 1?
it doesn't matter. You're finding just the possibilities, not the actual license plate number. So this would be how many? 20,000. Do you see how one tiny little restriction really affects the total number of possibilities that could be there? All right, same type thing, ATM code. They tell you that the ATM code consists of 4 digits. 1, 2, 3, 4. How many digits are there? 10. Doesn't tell us anything else, so that it doesn't say anything about repeating. So how many different ATM codes can I have? 10,000, good. All right, same thing. 4 digit. It says the 4th digit is not a 0. So this digit cannot be 0. It could be anything else but a 0. So how many options are for that last spot? 9. How about for the rest of them? Perfect. Good job, guys. So I get 9,000. All right. How do we feel? You guys are going to have not a bunch of questions like this, but these type questions, when it gives you a bunch of options, all you're doing is multiplying together. Here it says a college, you're preparing your schedule. You have to pick 1 of 4 math courses, 1 of 4 science courses, and 1 of 2 social studies and humanities. How many are possible? Well, how many different classes can you choose? 3 different ones, right? How many math courses are available? 4, good. How many, what is it, science? How many science are available? 4. And then what? Good. So all the possibilities, we multiply them together and we get how much? 32. 32 different schedules you can make. All right, 9 says the customer can choose 4 amplifiers, 9 stereo receivers, speakers. So how many different things are we picking? 3 different things. Of those 3 different things, how many amplifiers do we have? 4. How many stereo receivers? 9. And then how many speaker models? 10. Do you guys even know what a stereo looks like? 4 times 9 times 10. 360. I don't mean the one in your car. I mean like a stereo like in your house. Oh, nice. All right, this type of question, again, this is all about semantics, all about what the words are saying. It says, how many ways can a 14-question true-false exam be answered? Think about this. I'm going to visually show you this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, here's your 14-question test. What kind of a test is it? True or false? Well, for the first question, how many answers could I put? 2 different ones, right? True or false? What about for the second question? 2. What about for the third? And then do you guys agree with this? It's 2 to the 14th power. Now, if you had a multiple choice, say you had a 14-question test, it was multiple choice, and there was 4 answer choices. It would be 4 to the 14th power. What about if there were 3 answer choices? 3 to the 14th. Okay, good. What is 2 to the 14th power? 16,384. Good. Multiple choice question tests, true-false question test. Figure out how many questions there are, and then figure out how many answer choices there are. What if they said, how many different ways could if there's a 20-question test? Think about this. Does order matter or not? What's the thing that I'm telling you? I have a 20-question test, and I have to answer 14 questions. Does order matter? Yes or no? Why not, George? You're right.
Doesn't matter which question.
Doesn't matter. It doesn't tell you have to do the 1, then 2, then 3. So that would be a combination, right? So think about that. When you get questions, and the first thing you should ask yourself is, does the order matter? And then you can put it out, or you can actually use the formulas. It doesn't matter. All right, 11. In this physiology class, the student must dissect 3 different specimens. The student can select 1 of 6, 1 of 7, 1 of 3. What am I doing with these 3 things? Yep. I don't even want to read this question. It's gross. How many different earthworms can we pick from? 6. Ugh. How many different frogs? 7. And how many different fetal pigs? Oh. What does that equal? 126. All right, finding the probability. What's probability again? Want over total. Good. Probability of drawing 2 marbles without replacement from a bag containing 1 green, 2 yellow, 3 red. First thing I do when I see a question like this is I write down the total. How many marbles are we talking about? 6 marbles. So 6 total. That's the easiest thing to do. Now it tells you they want to know the probability that both are red, and it says what? That means I do not put it back. So what happens to my denominator? Changes. It goes down 1. Now they want both marbles to be red, right? We're going to choose 1 at a time. So I'm going to choose 1, and I'm going to choose another one. So what do I do to those 2 numbers? Multiply. So what is the probability that the first marble is red? Yep, it's 3 out of 6, right? Which is 1/2. You can go ahead and simplify that if you want. So I assume that the marble that I chose was red. So when I go to put my hand back in, how many marbles are left in the bag? 5. And how many of those marbles are red? Very good. So this leaves you with 6 out of 30. Do we ever leave anything unsimplified? No. So what would you get? What is it? 1/5, 1/5. Now, read the directions. If it doesn't specify, I would just leave it as a fraction. But if it says write your answer as a percentage or something, then how would we change that to a percent? 20%. Good. All right, find the probability of drawing 2 marbles, again, without replacement from a bag containing 3 green, 3 yellow, 4 red. All right, what's the total? 10 total, good. All right, now let's read what this says. It says that neither of them is yellow. So I'm going to put my hand in and grab one, and I'm going to put my hand in and grab again, but I don't want them to be yellow. So let's think about this, guys. There's 10 total, right? Of those 10, how many are not yellow? 7 out of 10. Very good. If I wanted yellow, what would my fraction be? 3 out of 10. Good. So, and I want the second one to, again, not be yellow. So how many are left in my bag? 6 yellow. I have a total how many? 9, because I did not replace. So you get 42 over 90, which reduces to, which reduces to 7 over 15. All right, now we're talking about deck of cards. Guys, you need to know the deck of cards. If you still don't, pull it up so it's next to you. But it says find the probability of selecting one card from a standard deck of 52 that the card is a face card. All right, how many total cards do you have?
12.
52. Good. How many of them are face cards? 12. Do we have to add or anything to this? No, you just got to simplify. What's 12 over 52 simplify to? 3 over 13. Good. Now again, with cards and marbles and stuff, if they don't specify, just leave it as a fraction. All right, find the probability again out of 52 that the card is a black card. How many cards in a deck are black? 26. Half of them are. What's 26 out of 52? 1/2. What would the probability be if you wanted a red card? 26 out of 52, same thing. All right, find the probability of the experiment, blah, 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 blah. The card is between 2 and 10. Okay, so again, there's 52. How many 2s are there? 4. How many 3s are there?
4.
How many 4s?
4.
How many 5s? How many 6s? 4. How many 7s? 4. How many 8s? 4. How many 9s? 4. How many 10s? 4. All right? Everybody okay with that? Okay, so how many is that total? 1, 2, 3, 4, 5, 6, 7, 8, 9. What's 9 times 4? 36, which simplifies to 9 over 13. All right, how are we doing? Good? All right, these table questions. We like these table questions because they're easy. When I see a table question, the first thing I do, just like with the bag of marbles, is find the total. What is the total number of students we're talking about here? 39. Because probability is what you want over the total, right? Want over total. So this question is asking, out of 39 students, they want younger than 22. So where do I look? 18 through 19 and 20 to 21, right? Both of those age groups are younger than 22. Everybody agree? So how many is that? 36 out of 39. What does that reduce to? 12 out of 13. Good, guys. All right, we're back to a deck of cards. A card is selected at random from a deck of 52. It's always going to say that. The card is a face card or a black card. So I'm going to just write this out for you. It's a probability of a face. What does the word or mean again? Add, or the probability of a black card. Is this a mutually exclusive event or is this an overlapping event? Why is it overlapping? Because you can have a black card that has a face on it. So you have to subtract the face cards that are black. Okay, so think about this. How many face cards are there in a deck? 12 out of 52. Close enough, that's fine. Well, how many black cards are there? 26 out of 52. Of those black and face cards, how many are black and also have a face on them? 6 out of 52. The reason you have to subtract the overlapping is because if you don't, you're calculating double. You're calculating black and you're calculating face, so you're not getting an accurate count. What's 12 plus 26 minus 6? 32 over 52 equals 8 over 13. Very good, guys. What about the probability here? Probability of a heart, the word or means to add, or the probability of a diamond. Mutually exclusive or overlapping? Mutually exclusive. If you're not sure, say in your mind, is there a card that has a heart and a diamond on it? No. They have a suit, which is diamonds, clubs, spades, hearts, and then they have a number or a face, but they don't have two suits together. Thanks. So how many hearts are there in a deck? 13 out of 52. There's 4 suits. How many diamonds are there? 13 out of 52. So what's the probability that you get a heart or a diamond? 1/2. Good. Very good, guys. Oh, back to a table. What should I do once I see a table? Total it. How many total people am I talking about? 14. Yep, 30 total. Probability again is want over total. So the total is 30. I want 18 to 21. 14. God bless you. 18 to 19 is 14. I want 18 to 21. Do I have to add the 12 to it as well? So it's how much? 26 out of 30, which gives me 13 over 15. Great. You can answer 16 questions from a total of 20 on the exam. How many different ways can you select the questions? Are they telling you you have to answer in a certain order? They're just telling you there's 20 questions total, right? And you have to choose 16 of them. Does everybody see that? So I can use my combination. So it's 20 factorial over 20 minus 16 factorial, right? Times 16 factorial. Is that how that works? You guys agree with me? So 20 factorial over 16 factorial, 4 factorial. So 20, 19, 18, 17. I'm going to stop at 16. And I have 4, 3, 2, and 1. 4 goes into 20. I'm going to say 5 times here. 3 goes into 18. How many times? 6? Right? All right, so 5 times 19 times 6 times 17, and then divide that by 2. What is it? 48, 45. It does not matter what order you choose them. If it said you have to arrange, does order matter? Yes. When they use the word arrange, how many ways can you arrange books on a shelf? People in a row, something like that. That's when order matters. All right, how many different ways can 12 people be selected for a jury? You're all doing the same job. If George and Alexa and Kaylee were all picked for the same jury, it doesn't matter who's picked first because they're all sitting in one room doing the same thing, right? So how many people total are we talking about? 30. And how many are we going to choose? 12 of them. So this would be 30 factorial over 30 minus 12, and then 12 factorial. That's what I need to see. I need to see at least that. Most of you will show me more than that, but I need to see that you understand it is a combination. So I have 30 times, well, we'll do this. What's 30 minus 12? 18? 30. This is a long one to write out. 29, 28, 27. Stop at 18, right? We'll put 18 factorial right here. So then I have 12 times 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. So 18's cancel. Now this is one, if you're going to write it all out, not just do it all in your calculator, you got to be real careful. If you try to just put this whole thing in your calculator, I'm sure it'll say overflow. So when you cancel, that is perfectly fine. Just make sure that you take your time. I'm going to say 2 goes into 20 10 times. Agreed? 3 into 21, 7. 4 into 24, 6. 5 into 25, 5. 6 into 6. You guys okay with that? All right, 7 into 28 is 4. Everybody with me?
6 into 6.
8 can become a 2, right? And that 4 can go away. And then this 2 can go away, and this can become a 11. You guys okay with that? 9 here, and 27, this becomes a 3. 10 here, and this becomes a 3. We good? 12. What can 12 go into? Into the... Well, I'll make this a 4, and then maybe this 3 can go away. I can cross this 4 out, make it a 2, and make this 5 here, this 11 here, and the 11 here. However you guys want to do it, it's totally up to you. You can do all of this in your calculator, but I think if you try and multiply the whole thing out together, it'll be gross. But when you work all of this out, you get 86,493,225. Again, the way that I cross cancel might be different than the way you did. No big deal. Just make sure that you guys are taking your time and you're staying organized. All right, let's look at 23. This one was on your WebAssign. I pulled all of these from WebAssign so you could see. Does anybody have any idea how to even look at this problem?
Yeah.
Okay, talk to me. Law office, hold on, let me read, I'm sorry. Law office interviews paralegals. Does it matter, guys, if you know what a paralegal is or not? No. They're telling you that there's 10 openings. There's 15 paralegals with 2 years of experience, and there's 22 paralegals with 1 year. How many combinations of 6 parallels with 2 and 4 parallels with 1? Are we doing the same job, or do you have to pick certain paralegals in order, first, second, third, fourth? Same job. So is this a combination or a permutation? Okay, Madison, talk to me.
Well, I just did 10 spaces,
Okay.
and then I did 15, 14, 13, 12, 11, 10, and then 22, 21, 20, 19.
Perfect. So you did 10 spaces like this, 3, 4. And how many times did you do those 10 spaces?
6 and then 4.
But you did them twice, right? A set of
Yeah.
10 and a set of 10. Good. You did 2 combinations, which is exactly what it is. You're having 2 combinations. You have a combination of people that had 2 years experience versus 1 year experience, right? I had 15 to choose from that had how much experience? 2 years? How many of those 2 years do I want to choose? 6. Did everybody see that? Yeah? All right, look at the next one. How many did I have to choose from? 22. And how many did I pick? 4. So the way that this is set up, perfectly fine the way Madison did it. She did the first combination. God bless you. She did the second combination. That's perfect. You multiply them together. God bless you. Or you can set it up this way. If you try and do this whole thing in your calculator, it might explode. Right? It's not going to work. It's too much at one time. So we're going to look at this, and we're going to say I have 15 factorial over 15 minus 6 factorial, 6 factorial, times 22 factorial over 22 minus 4 factorial, 4 factorial. Agreed? Okay, so I have 15 factorial. What's 15 minus 6? Good. Okay, just make sure we're still with me. 22 factorial. What's 22 minus 4? Good. So 15, 14, 13, 12, 11, 10. Stop at 9. And then we have 6, 5, 4, 3, 2. Times 22, 21, 20, 19. Stop at 18. 4, 3, 2, and then I have 18 factorial. You guys with me? Anybody have any questions? You guys doing great. This first, however you cross cancel, top and bottom, whatever you guys want to do, this works out to 5005. And over here works out to 7315. Does anybody have any idea why I'm multiplying these two together?
These are two combinations.
Because I'm choosing 6 of these and 4 of these, right? If it said I want 6 of this kind or 4 of this kind, what would I do? What's the word or mean to do? Add. Good. But I want 6 of these and I want 4 of these. So I'm going to multiply them together. And you get 36,611,575. Madison, great job. And not just Madison, everybody else who figured that out. But good. Very good. All right, first of all, I am very thankful that a lot of you actually worked on this over the weekend. You surprised your math mama. I appreciate it. All right, estimate the number of unemployed workers in the 25 to 44 age group. Round your answer to 2 decimal places. Okay. Now, the reason this question is a little difficult is because they're talking about people, right? And they're talking about estimate the number of unemployed workers. What is this chart given to you in? Percentages. So you have to do a little extra calculation here. The easiest way to look at this, all right? What's the percentage of people in this age group? 39%. So I would set this up and say 39 out of 100, right? It's 39 people out of 100%. But I want to know how many of those are people that are unemployed. Well, how many total people are we talking about? 11.46 million. That's a lot of people. So you're going to multiply this by 11.46 million. How did you look at doing that, Gabe?
I was on it for like 30 minutes and I
Yeah.
said it quick.
It's difficult because they don't give, like the other ones that we had, they gave you total number of people. Here, they gave it to you as a percentage. So you have to multiply the percentage, that fraction of people, by the total. Yes, sir.
Oh, you have to do it by over the total?
Yes.
0.39.
Say it again.
If you multiply 0.39,
What do you get if you do 0.39 times 11.46?
4,400,000.
It's 4 point, what is it?
4694.
So like 4.7, that's fine. That's exactly what we're doing. When you do 39 out of 100, that's the same as 0.39, right?
You have to round it and just leave it.
That's fine. I mean, it's whatever they say on the test. But if you did multiply by what a common mistake was, people multiplied 39 by the total here. And it's not 39, it's 39%, which is how many people out of 100? It's 39 out of 100. So yes, you could have multiplied by 0.39 because 0.39 is the same as 39 over 100. Good. All right, estimate the number of unemployed workers who are under 25. Well, what's the percentage of people that are under 25? God bless. How many?
B.
Say it again.
Are we doing B?
Yeah.
Isn't it 25 or older?
Yeah, it's like 81%.
Oh God, did I say under? Sorry, my bad. So it's 39%, right? Plus 29%, plus 3%, all out of 100. You guys agree? What is 39, 29, 3? What do you tell me? 71 out of 100. So you could say 71 out of 100 is what percentage? What's 71 out of 100? What's the percentage?
0.71.
Good, 0.71. And you times that by the total. And you get about how many? 8.14 million. It's a lot. All right. Now the next questions are a little different. They're asking for the probability. What's the probability that a person selected at random from the population is between the ages of 16 and 19? All right, 16 and 19. It's 12% of the population. Guys, is that already the probability? Yes, because probability is out of what? out of 100. So you could, it doesn't matter, like, what did they say? They didn't tell you how to do it. So if you answered 0.12, that's fine. If you answered 12 out of 100 and then simplified your fraction, that's fine too. They didn't specify. But since you're already in percentage, you don't really have to do anything. That's kind of a yucky question. It seems a lot harder than it is. What's the probability that a person is selected at random that's between 20 and 64? All right, well, how many people are between there? So you would say 17 plus 39, right? Plus 29? What is that? Did I miss one? So 85 what? Percent. That question is not meant to be anything more than it looks. It looks a lot harder than it is, but you're already in percentage. They just wanted you to see how you have to look at things depending upon how the information is given to you. They're not giving to you as total whole people on this chart. They're giving it to you as a percentage. So I look at the last one. It says, what's the probability that a person selected at random from the population unemployed is 45 or older? Who falls into that category, 45 or older? 29 plus 3, right? Which is how much? 32%. It's 32 out of 100, so it's 32%. Okay, good. I know this was long. I appreciate it. You guys need to know Pascals. What's the third row for Pascals? 1, 3, 3, 1. What's the fourth row? 1, 4, 6, 4, 1. Fifth row. 1, 5, 10, 10, 5, 1. Sixth row. 20, 15, 6, 1. Oh my gosh, seventh row? 1, 7, 21, 35. What is it? 35 again? Thank you guys.